All right, so for the last part of this chapter, we're going to examine a program, thinking about the construction first, then we're going to go into the code. What we want to do is build a simple card game. And we're going to assume it's a game like War or Gin Rummy, where we have a deck of cards and 2 players. But before we want to code, we want to think about the appropriate classes. And for each class, we want to draw the appropriate UML class diagram, right? So let's think about the relationship between some of the classes that we might have, right? We're going to have a game, right? And that might not be entirely intuitive at first, but you can definitely think about the fact that we're going to need definitely a deck, and we're definitely going to need a hand, right? Each person has a hand, and there's going to be one deck for the game, right? So you can see here that the deck is going to belong to the game, right? This is a composition because we have a solid diamond, and we have a hand which is going to belong to the game because it's a solid diamond. Your hand of cards isn't going to belong to anything else but the game that you're playing, right? So game is the containing class that's going to hold our deck in our hands, right? And so since we're playing a 2-player game, we can probably surmise that this is going to be a 2-to-1 ratio, right? And we can probably say that the deck to game is going to be a 1-to-1 ratio. For each class, we need to decide on the appropriate instance variables and put them in the middle part of the class's rectangle, right? So when we're talking about UML notation for a class diagram, we have the top is the class name, and then the middle is the variables, and then the bottom is the methods, right? So for each class, we also need to decide on the appropriate public methods and put their declarations in the bottom part of it, right? So we got class name, instance variables, and public methods. And finally, we want to look for common instance variables and methods. If 2 or more classes contain a set of common instance variables and/or methods, we want to implement them as a superclass and move their common entities to the superclass. For each subclass or superclass pair, then we're going to draw an arrow from the subclass to the superclass to indicate the inheritance relationship, as we've seen on previous slides. So what does all that look like, right? Well, first, let's make our first attempt, okay? So in our game class, we're probably going to need variables to keep track of our deck and our 2 hands. So we've got a private deck called deck, and we got a private P1 or person 1 hand, and whoops, that should be a capital right there, right? Okay, so that's a capital H. Of course, we also need a way to play our game, right? So we're probably going to have a method, a public method called play a game. So once we instantiate our deck, or once we instantiate our game, then we can probably play it. So you'll notice the access modifiers. We have a private deck and a private player 1 hand and a private player 2 hand. So we're not necessarily going to be accessing these things directly. Now with our deck, we're probably going to have a lot going on, right? We're going to need an array to keep track of the cards, right? Of course, we'll need a card class, but we can come back to that. We also need to keep track of how many cards are currently in our deck, as well as what the total size of the deck is. Maybe we want to have like multiple decks enabled at some point, right? Or maybe we need to know how many cards are in the deck because, you know, if deck size is 0, we're out of cards, right? We also need to add methods to our deck, or methods that our deck can use. So we'll need to be able to get the current size. We need to be able to add a card, remove a card, display the deck, shuffle the deck, and deal a card, right? These are all things that you do every time you play a card game, right? So you need to think about the behaviors in real life situations. We also need a class to handle our hands. So let's add that now. Again, we're going to start with our variables. We need an array to keep track of the cards in our hand, as well as a variable to keep track of the number of cards in our hand. And as for our method, we need to be able to do the following. We got to be able to get the size, add the cards, remove the cards, display the cards, and sort the cards. So right now at this point, you should be realizing like, hey, wait a minute, there's some commonality between these. Maybe we can create a superclass and specialize these individually, right? Because we got current size, right? We've got the same array. Look at this, we got similar methods. Add card. That's a typo. That should be there should be a card parameter in here. Remove card, right, and display. So 4 of the methods are the same, and 2 of the properties or attributes are the same as well. So that's a great place to look for generalization, to pull these things out and to put them into a parent class. So here's the full UML class diagram for the program we're going to look at. We thought about things and we pulled out some of the commonality from deck and hand and put it into a new method, or excuse me, a new class called group of cards right here. So, and you can see all of the common stuff that they had together, right? These properties or attributes and these methods. But what are the relationships between the various classes? Let's take a look at that again just as a refresher, right? What about deck and group of cards? I'm talking about this relationship right here. Hopefully you realize that it's inheritance, right? Because deck is going to inherit from group of cards. Well, what about hand and group of cards? What is this relationship? Well, it's the same, right? It's inheritance. Hand is inheriting properties and methods from group of cards. What about card and group of cards, right? This is a many-to-one relationship, right? But is it a composition or is it a aggregation? Well, hopefully you looked and see that there's a solid black diamond here, right? This is solid. And so that means it's a composition. Card is not going to belong to anything else but a group of cards, because a card cannot belong to a deck and a hand at the same time, right? It's got to be in one or the other. What about game and deck? What is the relationship there? Right? We have a one-to-one relationship. That's a composition as well, right? A deck is only going to belong to one game. And finally, we have our hand and game relationship, in which we have a 2-to-1 relationship because we're going to have 2 hands, one for each player, and only one game. And again, we have an aggregation, or excuse me, a composition. Solid diamond, composition. Listen to, don't listen to my words. Don't worry if you're thinking that this is complicated and that you wouldn't have come up with this on your own. This process is iterative and it comes with practice. Generally, you won't have all the answers up front like we kind of did with this, working through this example. You're gonna sit down and you're gonna look at the problem at hand and you're gonna go through it iteratively. You're gonna be like, okay, well, we're gonna need this, and what about this, and what about that, right? And you're gonna get to the answer through a number of times of looking at the problem. So it helps to also collaborate with others, other programmers for design help. Maybe they've worked a program or a project that was similar, and they're like, oh yeah, you could set it up this way, right? But the key is to think about things in the term of objects, in the terms of composition and aggregation and inheritance. Find out where those similarities are. Figure out, is this object something that can belong to something else, or is it going to strictly belong to this class? Am I going to need many of them, or am I going to need just one, right? And so you think about these things and you lay it out using this UML notation before you even start coding, right? And this really helps you to think about the problem at hand. So now that we've gone through all that and you've looked at the actual code, or excuse me, you've looked at the diagram, let's dive into the actual code and we can see the program in its completeness. Okay, so here is our game class, and here you can see where we are declaring some private properties or attributes. We're declaring our deck like we said we would, and our 2 hands like we said we would. And so here is kind of the driver, right? We're going to create a new game and we're going to play the game. And that's pretty much it. And it's going to say, you want to play another game? And while equals yes, it's going to execute. So here is our play a game method, right? It's going to display the deck just for debugging purposes, and then it's going to shuffle it, right? And then it's going to deal out all the cards to 2 players. So while the deck is greater than 0, while the size is greater than 0, we're going to add cards to player 1's hands. And here we're going to add a card to player 2's hands, right? So we're just going to go one the other, just like you're playing cards. That's it. That's the game class. You can see here's our 3 properties, and here is our play a game method, right? And if we were to look at the class diagram that we had displayed, you would see that that is exactly what we had set out and said we were going to do. All right, so now let's take a look at the first thing we declare here. All right, we declared a deck, or actually, excuse me, we initialized the deck. So we go to deck, and you can see here that we have our total number of cards, right? And it's a constant set to 52. So if we ever need to change it, maybe we want to play with 4 decks, right? We can change the card count. So in our constructor, when we create a deck, look at what we do. We're going to add a card, and we're going to create a new card using this parameters, right? We're going to do some kind of mathematical operation, right? It's going to be 2 plus I mod 13, right? So that is going to give us essentially 2 through 15, right? Because we've got all the face cards in there as well, right? And then we are going to divide it I by 13. What this is going to do in effect is give us one of the suits, okay? Because there can only be 4 suits. So I mod 13, so for 13 cards, right, there's 13 cards in every suit, so we're going to go through all the cards, and then we're going to start over again, right? So we're going to have 4 2s, 4 3s, 4 4s, so on and so forth. But we'll look at that when we get into the card constructor. Here we have shuffle, right? And it just says, hey, we're shuffling the deck, shuffle, right? This is just, notice that these methods aren't even fully flushed out yet, all right? And then we're going to deal a card. Here we're printing out index deal card, right? And then we're going to remove a card and return null. All right? So we're just removing a card. That's all we're doing. All right. Any questions on that? All right. Now remember, look at this. We're calling remove card, but we don't have remove card declared here. Well, that's because we're going to find it in group of cards. Here we have an array list of card called cards, and our current size is 0, right? And we add a card. We add the card to the array list and increment our size. When we remove a card, right? Remove card. We say in remove card, and our current size minuses, and we return null. And then finally, we have our display option, or our display method, which is going to print out the suit and call the card display, right? If we go back and look at deck, we can see that we call remove card. We can see our group of cards. We have remove card declared or defined. We also said that our hand was very similar to our deck in that it extended the group of cards. So here we can say we have our in-hand sort, and here we can add a card, right? So we're adding the card, or to our hand, and here we're playing a card. So we're simply removing the card, and it's just a debug message so we can kind of follow what's going on. So the only thing we haven't really looked at yet is the card. Here we have card, we have its number and its suit, and its constructor is its number and an integer for a suit, right? And to print out the card, we just print out number and suit. That's it, right? So we have an integer, so instead of like, we could probably have done this with an enumerated type, which would probably have been a little bit smarter, but a little bit more complex, right? So if we go back to game and we run the game, we'll see it all come together. So let's run it. All right, so we run it, and you can see here that we're printing out all of the cards. So you can see we've got 2 through 14. I misspoke earlier. I said up to 15. I was off by 1. But we can see our suits here, right? We've got suits 0, 1, 2, and 3. And that corresponds to our 4 suits, right? So if we go back to game and we look at the main class, we're going to create a game, and then we're going to call game.playGame. And so we come in here and we display the deck, and then we shuffle it, right? So if we go back to our program, you can see here that we have displayed it. That's the first part of the program. And then we are in shuffle, right? So we're shuffling the deck, and then we're dealing a card. And then we're removing a card from the deck. And then we're adding a card, right? And then we're in the deck and we're dealing a card. And we're going through all of that over and 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 over 52 times until we are out of cards, right? So we hand out all the cards, and then we play all the cards. So that's the game. Obviously at this point it's not very exciting because we can play it again, right? And it's going to do essentially the same thing. It's going to create a deck. It's going to initiate or initialize the deck, which is as part of the play game function. We display the deck, right? And if we look at display, well, in deck there's no display function, so we go back to group of cards, its parent class, and look, there's display. And for every item, you know, we get the card and display it. All right, so that's the program. You saw how we put the things together. You saw the composition, you saw the inheritance, you saw the aggregation of all the different attributes and how they all came together and produced the software that does something. Now, obviously, this is just a stepping stone, right? This isn't a very interesting card game. It's not meant to be, right? It's supposed to demonstrate the shell of the application, because once you start adding in more and more functionality, it's going to be really hard to see the forest for the trees. You're going to get lost in all the lines of code at this point. So the whole point of the authors making the program like this is just so you can see how the classes come together, not necessarily to have a robust game that actually works and plays. But you have all the basics there, and you could actually take this code and you could modify it, and you could actually create a game out of it, right? Where you have 2 players and it does something. It'd be great. So that's the card game. Hopefully you got a little bit out of it to see it working and running and how all the pieces come together. You can see how it's really not that big, right? If I turn on my view line numbers, the game class itself is, 46 lines with comments. The card class itself is, not very big. It's 27 with comments, right? It's tiny. The deck, not that big. Group of cards, that's probably one of our bigger ones. Probably clocking in at what, like 70 lines? Nope, only 50. Okay, so it's not that big. So none of this is really an exceptional amount of code, but the fact that it does all this and works together is pretty cool, right? So that's the chapter, and this is the cards program. So in closing, we covered a lot of ground on some different theoretical topics such as composition, aggregation, inheritance. Know the difference between the 3 things. Understand that aggregation is a weaker form of composition. Composition being a whole thing is made up of subparts that belong solely to the whole, right? Your parts of your body belong solely to you, right? Aggregation is a weaker form of that, where everything makes up something bigger, but all those pieces can also belong to something else. And we looked at several different examples of that. We also looked at inheritance, where a subclass can inherit attributes and behaviors from a superclass, or a child class can inherit something from a parent class, right? We looked at method overriding, and that's where the method of a child class overrides the same method with the same signature of the parent class or the superclass. And then finally we looked at, comparing these 3 things, kind of like we just did. And we looked at how we could use all of them together, like in the card game, right? Where we had different forms of inheritance, we had inheritance and we had composition. So that's the chapter. Hopefully It was interesting because it was a little bit different than some of the other chapters in the book, and hope you really enjoyed it. And if you have any questions, as always, feel free to contact me. And if not, I will see you in class.